coding errors. Just press more buttons. When in doubt, just press more buttons, right? So I sent out a video on Tuesday showing you how to do the Eclipse CDT. I think that's a more robust compiler. It allows you to download the GCC compiler, which is the standard compiler. So I know a couple of students had emailed me. They had installed it. So there's a second one that I've put on Blackboard, the LCC Win, which is available from the University of Virginia. What I want you to do, one part of your assignment for this week is you're going to be doing group coding projects. I want, for those of you who can find 2 other people to work in a group with, find your 2 people and email them to me by Tuesday. And I want you to have installed one of the compilers on one of your machines and do Hello World. I want you to show that to me. That's on Tuesday, right? So those of you who cannot, if for whatever reason you've transferred in, you don't know 2 other people, that's fine. I'm sure there'll be other people and we'll assign to make sure you guys are in fair groups. Let's see what else. What else I need to tell you about? Yes?
What if we don't have a Windows machine?
What's that?
What if we don't have a Windows?
If all 3 of you don't have Windows?
Or what if one of us doesn't?
One of you does not have Windows, then there are other free Linux compilers online. I can hunt one down for you. Or you can Google. I know there's there's actually quite a few free Linux GCC compilers out there. When you submit your projects, you just have to tell me which compiler you used. For example, if you don't tell me which compiler you used, I will compile it using Eclipse. And if it doesn't run in Eclipse, then you'll lose much points. Okay? And especially since you're learning, computer architecture, where it's a compiler-driven encoding of the microengine, you should demonstrate that you understand the basics of compilers. So there's bound to be ways that you can contribute, as long as it finally all compiles on an appropriate machine. But if you're using GCC, it'll standardize. Yeah.
How do you want us to submit it?
I'll go into that in much. It'll be through Blackboard. You submit your code and a project description. Any other questions? Oh, you mean like on Tuesday?
Yes, sir.
Yeah, you'll submit your name, and I'll have a Hello World here. So basically what you're going to do is you're just going to have your Hello World in the format that I'm going to ask you to do it in. And then, so you include your hello world.c and just do a screen capture showing that you got it to run. So I'll include that in my email to the class after lecture. It's a good question. So, any other questions before we move on? Okay. So in order to execute a procedural code, you have to have a thorough understanding of what a function is. And a function is a group of statements that perform a task. So basically, you have your main function. For those of you who have coded in C++, I'm sure you're familiar with int main. But every C program will have some sort of int main, and where the main is the main driver function. That's where the program will start, and then functions are going to be called within main in order to execute your task. So a function is a group of statements. Let me add the of here for you. And it says in C, there's at least one function main. 2.7 is just defined function. So, as I warned you previous lecture, I am going to be very adamant about making sure you comment your code. And so when you name a function, there's going to be a set of things that I want you to do for every single function in your program. First, I'm going to have you write the function name. Then we're going to write what are known as preconditions and postconditions. So let me give you an example. And I'll be able to scroll down here. But basically, the whole idea of a precondition or a postcondition. Let's say we have int add, and then we have int a, and int b, and it will say return A plus B. Very simple function, right? So our preconditions are these two values into A and in B. These are the inputs to the function. Postconditions are the function output. So you'll say int A and B, postconditions int. And then one sentence description of the function. What the function actually does. In this case, with the one I've drawn up here, is that this function takes in two integers and returns their sum. And then you're going to include test cases. So for those of you who will be taking control systems with Dr. Daigle, which is all of you since you're electrical engineers, this is something he's very adamant about and gets frustrated when students don't do. So if you want a better grade in control systems, remember this TGO and put that into practice. So for example, this would be simple, but you say A equals 1, B equals 1, return 2. A equals 1, B equals -1, return 0. And that's simple, but once you start getting into more complicated functions, having test cases becomes important. So, yes?
How many test cases are we?
Now, that's a very good question. What you're going to be doing in your projects is, for example, I'll have you design an AND gate. So you're going to have bool A, bool B, return bool, and then you're going to design this function test AND gate, right? So what you can say here is the full set of test cases is in the function AND test. And I'll show you examples of that as we go on through lecture. So either something that just shows a couple of test cases indicating that you can actually test the function and it works, or if you've designed a test function, you can actually list the test function there. And so a lot of cases, we're going to be dealing with this concept of what's known as a header file. Is a C file that's ending in .h. So if for your first major project, you're going to be creating a gates.h file. And then your gates.h file will have your function declarations. And then the .c file, which we'll talk about later, will have the function definitions. So what I mean by declaration is, you have another place where you just got int add, int ab, semicolon. Which means I've declared this is what the function is. And oftentimes when people are looking at your code in the future, that's all they'll see. They won't be able to see what's going inside here. They'll just be able to see the function declaration, this function, and your commenting. So that's why the commenting is so important, so that way they can figure out what it is you were doing. Or you write some code, you don't deal with it for a couple of years, and then suddenly you need it again. You look at it and go, what the hell was I doing? Hopefully you know better. So, but header files is where you can put a common set of functions. Gates.h. If you're doing arithmetic, you can do an arith.h. If you're doing memory, you got mem.h. Anything that you think is a group of functions where it allows you to kind of come up with a library. So a header file is where you can create your library of functions. And C in the GCC compiler has some standard libraries, which we will discuss today as well. So let me read this definition. A header file is a C file ending in .h that contains C function declarations and macro definitions, and to be shared between several source files. They are included in with the pound include command. Do not say hashtag. I will kick you out of class. So it is pound include, and what that means is at the top you're going to be So again, let's say we have gates.h, and we're in our we're calling our main function nips.c, and so we have int main, and we have to call gate functions using this library. At the very top, you're going to see pound include, and then in quotes gates.h. Semicolon at the end. So that says everything that is in that function may now be called within the other file. So that allows you to minimize the amount of code you're going to have to write. And in section 4, when we start talking about how to actually compile C code into MIPS, that's going to become very valuable. So instead of saying, all right, I need another set of instructions in my instruction memory, I can just create a pointer to where the .h files instructions begin. It allows you to significantly reduce your code space. Okay, so here I kind of briefly talk about when you're using libraries, allows you to have the same procedures throughout each function, cross-references, saving time by not needing to code extensive data layouts, which is what I was just describing. Sometimes you have to, just by using a pound include, you're reducing your amount of code in your main function. And it allows for code reuse. Code reuse is a very important consideration when you write code. So instead of writing the same loop 4 or 5 times, you just write a function, do it, have the same inputs, and run it again. Okay, so 2.10 is the header file called stdio.h, which stands for the standard IO library. So it's standard input output. So we have 2 functions here that I'm describing. One of them is the TGO 2.11 here. So printf basically takes a pointer to characters or a string. So you have char 0, 1, 2, 3, and then you have a null terminator. And just prints it out to this. If you're using printf, it'll just print it to the screen. In this course, we're going to be focusing on I/O of architecture, and so it's not going to be sufficient because you're going to have to update memory, and we're going to simulate that by updating text files. So you're going to have a text file that represents your instruction memory, you're going to have a text file that represents your data memory, and you're going to be writing to those as well. So therefore, in this course, I am not going to permit the use of printf because now, by using fprintf, first of all, fprintf is more of a stable function anyway, so your code will be better. Additionally, fprintf, the first element here is file stream. So you can either indicate where your stream is going to be. So if you're writing a basic hello world function, you'd use fprintf and then std out. If you just do standard out, that's in your studio.h file. And then you would write hello world and then in the function. If you actually had declared a file, which I'll teach you how to do later when we get into memory, then you would actually indicate the file stream and then where you want it printed. So in order to meet that objective, I am restricting what you're permitted to use to fprintf. So I'll read this definition for fprintf. So file is a pointer to stream, file star stream, and we'll go over in more detail what a pointer physically is later. But right now, just good old. I should tell you a quick Navy story. When I was in nuclear power school, they would teach things that were, in order to understand it in more detail, it would be covered a little later in the course, just like right now. Right now, we have the star pointer. We're going to be going over detail of pointers a lot more. But right now, just nod and smile. Don't. They would draw this. One of my instructors drew up this big circle and just wrote, "I believe." So he would say, right now, you just got to press the I believe button. There's a pointer. We will learn about it later, but right now, I believe. So if you ever hear me say, just press the I believe button, I promise I'll be answering the question in more detail later in the course. So allows the user to dictate the stream, whether output file or stream. So if you're creating a stream to a file, you're actually creating what's known as a file stream, where it actually dictates the characters will go to the file, and then rewritten. If successful, the total number of characters written is returned. That's why it's an int. So even though if you're going to write fprintf, the number of characters that are actually printed is returned by the function. If it's a failure, it'll return a negative number. So if for some reason, if you're trying to maintain data reliability, and we are simulating writing to memory using fprintf, what could you do to ensure that you actually wrote to the file or not. I want to write a test case. Did this actually write to the file?
You can print out the content of the file.
You can use that. You can either print out the contents of the file or the function returns a number, right? So what you can do is you can go if fprintf file stream greater than or equal to 0, then proceed. Or if not, then you have to say something to the user or do something, right? So if fprintf is less than 0, so it's a negative number, that means it didn't print to the stream for some reason. Either the file doesn't exist, or you didn't provide it the right information, something went wrong. So when you see, and I'll emphasize this a lot, test cases and making sure that your file streams and everything are taken care of and be properly tested to, one, make sure the file is actually there. If you have an input stream and the file's not there, you're just going to read a bunch of garbage, or your function will just throw a segmentation fault. Or if it's an output file, you want to make sure you're writing to the right place. Okay, so this is, I actually do want you to handwrite the hello world in this case, because it's not just the code, it's how I want you to write all of your files when you're actually coding. So at the top of every file, I want you to describe what the file is doing. So you have your file name, author. In your case, groups often come up with a team name. Like one of the teams last year was Team Ultron. I thought that was rather amusing. So you can write Team Ultron and then write your 3 names there. And have an email for somebody I can contact regarding the code. So this file is a main driver function for hello world. So I've got to describe what the function is doing. So at the top, you're going to write your libraries. So I wrote pound include. I want you to comment and say what the library is doing. So we're going to be including a number of different libraries. I'm going to teach you what they are. It is stunning to me when I talk to graduates of computer science, computer engineering, and what does stdih.h stand for? Yeah, right. I just told you it's a TGO, right? And they have not a clue. Hey, how do you? I just type it. So now, as you can see, I am not a hypocrite. I have my preconditions here, as I've described. Function main, preconditions none, postconditions int. You are allowed to have conditions for main, and you're not going to really need them in this course, but what will happen is int argc char star argv. So in many cases, this will have a string of arguments for an input function when you start the function, right? And the int is the length, is the number of arguments in this array, and char star is argv. Now we're actually going to describe why it's important that you include the integer. Short version before, I don't want to go too much into the I believe button world, but remember we were talking about the pointer to load word? If you have a pointer, the pointer indicates a block of memory. So I have a block of memory indicating a set number of characters. Each character takes a certain amount of memory. So if I know character takes 32 bits, and I have, or we'll talk about byte addressing of it. So here are my 32 bits, and then I have my next 32 bits for character, string, and so forth. If I say this is 5, I won't go to the 6th one where there may be a bunch of garbage or something else, right? So that indicates I have a character, a array of characters, and I know precisely how many they are. So that's good memory management. But in this case for hello world, you don't need to worry about that because you're just printing to a stream. So we have used fprintf. I've used standard out, hello world, and I've done return 0. If you're looking up C code you sometimes will see return and there'll be all uppercase exit success. That is actually in the standard IO library. That just means return 0. If you return a negative number, that means your function didn't work. And oftentimes, if you, for example, let's say you're writing a function where the first thing you need to do, you ask the user to tell you a file name. So they tell you file name george.txt. You look for george.txt. There is no george.txt where they're looking for. So you would say if the file doesn't exist, then print to user file does not exist. Please restart program. And then you would do exit -1. Which then would return -1 to main, which would indicate to the operating system, stop the program. And so as I've indicated, the return 0 in main indicates to the operating system the program has completed successfully. So I'm going to scroll up past 2.12. So I've kind of given a brief description here of how to do LCC Win. You can download it. Then you go to File, New File, type helloworld.c to create the file. Write your Hello World code as I have described here. So what I want you to do is I want you to type up this code for the project, put your name and email here, and then run it whether you're using Eclipse or LCC Win. And then compiler and make, and using LCC Win, you'll get this little black box, and if you can barely see it, but we'll go back to 102 in a second here. So you go to 200, you can see it says Hello World. So next thing I want to do is I wanted to write a basic performance problem using C. So if you remember from last lecture, we had computer A does a program in 15 seconds, computer B runs it in 10. Which one has the better performance and why? So we're going to talk about this concept of a float. Now, integers don't have decimals, right? So we have to convey decimals using different types of functions. And we will describe in section 3 specifically what a float is. How many of you in C++ are vaguely familiar with floats and doubles, right? So we're going to go into what a float is and what a double is. A double is double of float. So float is 32-bit representation of scientific notation in binary. Since MIPS is a 32-bit data path, you're going to be using floats in your code. You may not use double because you simply don't have 64 bits. And then the specific format is IEEE 754, which we'll go into more detail. Okay, so a function prototype is the declaration of function. I alluded to this a little earlier today. The function prototype is a declaration of a function that specifies the function's name and type signature, but omits the function body. Just like this, right? The function body is where we would return A plus B. So what I mean, for those of you who you should be vaguely familiar with since you've done it in Java, but return is you get the function, and then what's going to physically happen is in the instruction memory, the function indicates a specific space. And when you compile it down, what we're going to do is something called jump return. And jump return indicates the element in the instruction memory where the instruction after the function is. So you call, if you're in main, you say A equals 1, B equals 2, int C equals add AB, right? And then you're going to have next, let's say fprintf standard out C equals, and then you indicate what the C value is. What this return function, what this turn code actually means is jump return, and it's going to tell you where the instruction is in instruction memory for that fprintf function. So the function prototype is what you're going to have when we start talking about header files here in a minute. But what we're going to be doing is we're going to include this by having a function here. So what we're doing is, I had 2 floats, and I'm going to return a float. So if I have 15 divided by 10, and I made them integers, and I returned an integer, what would it return? 2? What's going to happen here? So if the actual answer is 1.5, right? So what do you think will happen?
It goes to the integer.
Goes to the integer. So it'll return 1. I see what you're saying, though. It might try to round up. Yeah, it just chops up. It's a good. You're thinking right. Just truncates it, though. It would be nice if it did that, though. Like this was 1.9 rounded up. Fortunately, the compiler is not that kind. So here I have included my function declaration. I've done main as before, test case from the C programming language textbook, and then I have my function definition down here. I have my function name preconditions, postconditions. I've called the function perf AB, for performance AB, preconditions float AB, postconditions float. The function returns A divided by B, and then test case A equals 15, B equals 10, return 1.5. And so here, what I've done is I have my int main function, and so this is where you can start taking advantage of your I/O. So what I've done here, I've standard out, and then if you're going to put what you're going to print out in double quotes here like this, right? So when the basic ones you're going to use, if you do %C, that's going to be a character. You do %D, that's going to be an integer, and then %F is going to be either a float or a double. In this course, it'll be a float. And so as you can see, and we'll describe why this becomes important in a second here. So we have a float, and then after the quotes, you're going to write a comma, and then your argument. So if I had another integer, so if I had said int b equals 5 before that, and then I did fprintf, sorry, I had the std out, and then quote %f, comma, %d, and then after that, I would do comma, perf a, 1510, that will return my function. Then I can do comma, int b equals 5. So I can just say b here. And then now this %f would be in order, and then this next one should be an integer. So this would print out 1.5 and then 2. I'm sorry, 5. And so I ran the function, and we can see it returns 1.5 and then 0, 0, 0, 0, 0. Any theory as to why it returns this many digits? We did not specify it. You can actually specify it in C. So if I did %3f, it would say 1.50. Right? But why do you think that's the standard?
32-bit.
Yeah, because of 32-bit, right? So it's actually we want to indicate a certain number of decimal points, and when we get into IEEE 754, you'll be able to convert from binary to integer, and this is the number of decimal places it can accurately convey. So that's why the architecture, knowing the understanding of the architecture, becomes important. So, does anybody have any questions on this so far?
So you have the A divided by D, and that's what your actual function is. But above that's I guess your main.
Right.
You see that your main, and that's you're printing out.
Correct.
You're printing out what your function is down below.
Yep.
Would it matter what order?
Yes, that's a very good question. Now, if you had these functions as a header file, you would have, let's say we just do perf perf.h. Let me move this down just a second so you can see precisely what I want. So in a header file, you would have this in your header, and then you would have perf.h, and then you would have another function, perf.c, and I'll show you examples of this, where you'd have pound include perf.h, because you have to have the function declaration and then the function definition. And then you put pound include perf.h in main, and then all you would do is call perf.ab here. So it does matter. You have to have your function declarations, then main, then the function definition down below. But what you're going to do is you're going to create header files so you never have to worry about that.
And like at the perf, that's a file.
No, well, oh yeah, perf is, yeah. We'll get there today. I promise. So, but yeah, you're on the right. You're saying the right things. Any other questions? But I just want to give this as an example of how declarations and definitions work before we get into header files. So now we're going to start talking about program structure. Boom. Start answering this question. So at this point, you should be familiar with if, else, for, and while statements. Does anybody not know what a while loop is? All right, good. All right, so in this course, especially when we start dealing with Booleans, we're going to start talking about switches. So for example, when you write an AND function or an OR function or anything else, I want you to actually kind of get familiar with how it's physically working from the ground up. So if you're doing a 32-bit adder, you can't just write A plus B. You're actually design the Boolean structure of the 32-bit adder. And you're going to do that using switch statements. So a switch statement is a multiple selection structure that selects one of the cases and executes that procedure only. The reason why switch structures are important is because it'll say switch, and you'll have the variable, and then you'll have a set of cases. When it tells the case, it'll find that specific case, it'll execute that, and then get out of this switch function. It's better than if this, if else this, if else this, if else this. So it's meant to improve computing performance. And what's the goal of MIPS?
To improve computer performance.
Yep, high performance execution of compiled code, right? So hence switch statements. And so next I'm going to give an example here of some C code where we're actually doing a switch statement. And so I have creatively named it switch function. And so switch function int. And so I have main driver function. I have created value val 20, switch function val, return 0, right? And so here I have my switch function. So what's going to happen here is that it's going to take val here, and it's going to go through all these cases and see what I want. So all of them, it's very simple. All of them say false except for case 5, which says 2. And then if it's the case that we're getting is not one of our cases, then it's just going to say error. So I put in 20. So what should happen? It's to say error, right? So you would, in your function declaration, you would say that we expect a value between 1 and 5. And then your test cases could be 1, false, prints false, 5, prints true, 10, prints error. So, and again, since we're doing an advanced digital system course, you're going to be using Boolean. So I've alluded to this, but I wanted to make this as a TGO as well. For the fprintf function, the following format specifications are used to print values to the output. So %d is ints and booleans. %f is a float. %c is character. %s is a string. And you're going to use \n for enter, \t for tab. And I know some of you had C++ coding. I know it might be boring you to tears, but a number of other students have not. So I'm teaching the courses, though I've assumed you do not have C++ coding. So again, if I had a char string, I could just, you know, we have this char star argv, right? And then I could go, since into argc, so if I wanted to do f printf, giving you an example of string, and then a standard out, and then I could do %s, and then I could go argv3, provided that this is greater than 3, or greater than or equal to 3. And then it would print whatever the input argument was. So the %s is actually just talking to a pointer for a char string, and then that string is going to be indicated by memory, and it's going to print just that out to the standard output string. And then if you wanted to get a little creative for doing a loop, you could do from I equals 0, I is less than argc, I plus plus, so now you're incrementing, and then you can say f printf quotes s \n. So now I'm printing all of the arguments that the user input to main.
How do you make an input? How do you make it so a user can type in a value? What type of, how would you code that in C?
Oh, we will get there. You're going to be using a standard I/O, and you're going to be using input and output streams. So you could use stdin, you know, get character, get string. There are multiple ways to do this. So again, I print out C here, and now I have this case where I've main. Now I've done int A, B, float C and D. These are I've declared functions, and then I have A equals 15, B equals A divided by 2. So what is A going to be? Yeah, it's going to be 7, right? So I'm attempting to store 7.5 as an integer. So now I have a set of print here. So now I have int B. Let me zoom in just a little bit so you can see the code here. 125. So int B equals %D. So here we have f printf standard out. Int B equals %D \n comma B. Here, int B as float. So now I have %f \nb. Int B with 6D equals %6D, which one of you was just talking about earlier. And B, and then int B with 0.6D. So we're going to talk, what do you think all of these are going to print out? We're going to make some predictions here. What's this first one going to print out? 7. What's the second one going to print out? 7.5? Okay, we'll put 7.5. Okay, int B with 6D. What do you think is going to happen here? Bear in mind, it is an int. Is this an integer? Okay, so let's compare these two here. So we have int B with 0.6D as opposed to 6D. So if I'm using this 6 as a placeholder, what do you think it's going to do here? All right, so it's just going to add 6 placeholder, so 7 is going to be over here. And if I add 0.6, it's just going to make that. Okay, and so I will scroll down to our solutions. Oh, we were wrong. Int B is float, 0.0000000. Why do you think that was? Because it was an int. But what's specific? Let's go a little deeper into what the architecture is. So what is a 32-bit value of 7? It's 29 zeros, and it's going to be 111 at the end, right? So going in a little deeper into what IEEE 754 is, it's a format where the first bit indicates positive or negative. So it's 0, it's positive. And then the next 8 bits indicate power. So it'd be 2 to the e minus 128, right? So in this case, it's 0 minus 128. So right now we have 2 to the negative 128, right? And then the rest of the bits are 1 plus whatever that value is. So these are all zeros all the way down to 111, right? So this becomes 1.0000000000111 in binary times 2 to the negative 128. So representing that in binary essentially becomes all zeros. So that's why understanding the architecture matters, because when you're troubleshooting your code, you're like, well, I expected 7, but I got 0.0000. That's weird. So when we go into section 3 in more detail about IEEE 754, that will make even more sense. So then, as you all predicted, we have our space holder and our 6 spaces where we have 1, 2, 3, 4, 5, and then 7 is the last spot. Yes?
I guess 64-bit would be the same thing except double.
Yeah. Your double would you'd have 50. You have 50. That 20 last 23 bits is what's known as a mantissa. In IEEE 754 for a double, it's 54 bits, and then you have 1, so that becomes 55, and then you're going to have 9 bits to indicate the power. So, okay, so the second set of printouts here, we have 15.3 is a float, and then 15.3 divided by 3 is going to be D. Let me move this up here so those of you in the back can see. So I have 2 floats in this function, and now I'm printing 3 things out. I have float D %F, float D as 3.2%F, and then float D as int %D. So what do you think 3.2 is going to, well, first of all, what do you think this one's going to print out as? 5.1. So what's this one going to print out as? What do you think? 0.05.1. All right, so let me put up this guess. And then what do you think int D float D as int will be? What was that?
5.
5? Okay, let's see. So those are our guesses. So let's see what actually happened. So we got our float, we got 5.1, and then, ooh. Why do you think that happened?
Is it that IEEE thing that?
Yep. So to represent 5.1, we're going to have, remember it's 2 to the e minus 128, right? So we're going to have some sort of number, so it's 1.1010 times 2 to the 2, right? So in order to have this represent, we have to have e minus 128 become 2. So this becomes e equals 130. So your first 9 bits of your number are 0, 1, 1. So that's 0, 0, and I get to add 2. And then 1, 0, 1, 0, and then a bunch of zeros. So now you're asking it to read that as an int. So now, so if it's 2 to the 31 is 0, 2 to the 30 is 1. So that's where you get this number from. So I even added the little I believe button time. But you see why it's coming out that way, and why. So this is a really good example of why understanding the underlying computer architecture will make you a better coder. So I've kind of told you all of that already. Yes?
Are there functions that better convert data types from?
Yeah, you can use casting. So so that's a good question. I wasn't sure if I wanted to address that in this course, but basically you can cast an int to a double or a double to an int, or I'm sorry, into a float and float to an int. And basically, if you have int 5, int a equals 5, and then if you want it for some reason you could do f printf standard out, and then quote %f, and then you can do what you would do is you would do float a like so, and it would actually cast it. So it actually would take that value, convert it to an IEEE 754, and then run it like that. It's a very good question. Anybody have any other questions before I kind of go on to binary values? All right. So the library for including binary values is stdbool standard boolean, stdbool.h. So you can see in this little code, I've started calling it mips.c. Here I have standard io.h, standard io library, stdbool equals, and I've commented it as boolean. Yes?
Now I guess it's all standard this, standard that. I guess there's such things that aren't standard.
Correct. And you're going to be learning how to write those.
Is it fun?
It depends on your definition of fun. Now, I think it's very important, not to sidestep your question, I think it's very important to understand how to code efficiently, because remember we were talking earlier in this section about how C compiles down to the machine language. So being able to write good and effective header files reduces the amount of machine code that you need in your instruction memory. So now you're reducing the size of your program and you're improving computing performance. Which, if that's fun for you, then cool. Okay. So here we haven't done header files yet. So first thing we do, we have our function declarations, and I have the descriptions below in main. So here I'm calling and test. I alluded to this a little earlier in lecture today, right? So underscore and test, and then return 0. So first thing I'm doing is I call and. So I have preconditions, bool A and B, postconditions bool. The function returns A and B, and all test cases are tested in underscore and gate. So you run, so this should be and test. I have mistyped. So here's how I say and test. This should say and test. So an and test, if you call and test, it'll print out all the test cases, which is what we're doing in this code. So my requirement, and you're going to be doing and, or, nan, nor, x, nor, and x, nor. So that's functionally, and then you can use that to build multiplexers, arithmetic logic units, and then we're also going to be talking about switch cases and to implement finite state machines. So you can't just put A and B. Sorry. But you understand what's actually going on here. So you have a switch case. So here I have case false. So with a switch variable as A. So if an AND gate brings in, if variable A in an AND gate is false, what does that mean? You're always going to return false. So if it's case false, you just return false. So what happens if if A is 1? Yeah, it's going to match the B output, right? So in this case, I return true, or case true, return B. And break, and I could say default return false, or you could have some sort of error statement there as well. Now here, what I've done next is I've created this function and test. There are no preconditions or postconditions because it has no inputs and doesn't have an output. But this function tests all possible input cases for underscore and. So I'd run void and test. I've declared bool A and B, declare the two bool inputs, and then I print to the user this is a 2 input and truth table. And so I have gone through all 4 test cases, and then I print the value out. As you can see, I %d, 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 \n. The first %d correlates to A. The second %d correlates to B, so this correlates here. The third %d calls to the actual function call of underscore and. And then it's false, 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 true, true, false, true, true. And it prints them all out. And then I like to put an fprintf. Let me scroll down here just for a little bit. I like to put an fprintf std out to make it clean, to give some space. So in LCC win, roll in, we have executed our function, and truth table 000, 001, 100, 111. So now that's how you demonstrate your test case. So let's go back to 125. So does anybody have any questions about what I did in terms of switch statements, fprintf, %d? Pretty straightforward. All right. So to address a question I got a little earlier, how do you make your own .h file? So in building your MIPS data path, you'll be able to create your own .h files. You want to create an arithmetic.h file, some memory.h files, and all kinds of other functions that will allow you to properly implement it. This will allow you to have a good design flow, allow for code reuse, and ultimately make your project easier. So if you try to put everything in one file, it's a disaster if you don't properly do that. So the first thing you need to do when you create a .h file, so here I have, assuming your header file is named headfile.h, each header file must begin with the following 2 lines. So pound ifn def, and then pound define. So what this means is pound if not defined, and then in all uppercase. So this assuming the header file is headfile.h, all uppercase headfile underscore h. And then if it's not defined, then define it. Pound define headfile underscore h. And then you're going to have your function declarations, meaning function declarations, not function definitions in your .h file. So this is where you're going to have you're going to describe what the function's doing, and then you're going to include everything else you need in here. And then at the end of the .h file, you're going to say pound end if, meaning if not defined, just like any if statement, right? So you're going to have brackets. Think of it this way. You have to end it. The number of times, in my experience, where I've written up what I thought was a beautiful .h file, compile code, it's not working, it won't compile, and I look at the bottom of my header file, I don't see end if, and I'm like, I'm an idiot, right? This is a good, so nowadays, whenever I write a header file, the first thing I do, if not defined, header, define it, and then I'll write end if before I write a line of code. I'll press save and then compile, and it'll compile. So here's how to create a header file. So let's say we're creating gates.h, which you will be doing for as part of your first coding project. So gates.h, if not defined, gates underscore h, pound defined, gates.h, and then here I've done include standard bool.h. We're going to be going over trees here in a minute of library trees, which I wish had been taught to me, so you guys are getting fun. Because if you don't have fun, we're discussing about what happens when you get circular library references. Short version, disaster. Here I have the function name as I've described, and I call bool underscore and then at the end, here you could have and if that's your only function, right? So here we have created a header file, and then in main, what we would do, and I actually kind of described down here, you actually would just call pound include gates.h and then run main, right? So here I have pound include gates.h. And then I have my .c file. So I have gates.h has just the function declarations, and gates.c has the function definition. So here, the first thing you're going to do is you're going to do pound include gates.h, and then you're going to have and as we've described before, we actually have our function here, right? And so this cuts off here. So now we're going to have mips.c. Here you can see that I have, so this is my new and truth. I could do and truth table, or I could create and test and just put that in my gates.h file. So, but the important thing to note here is that I have pound include studio.h and I have pound include gates.h. What don't I have in the mips.c file that I had before in terms of library? What's the other library we've talked about today? Standard Boolean. So why didn't I include it here? So it's already in gates.h, right? So now that I have it there, I don't have to do it again. And knowing that, yes.
So predefined libraries are in the brackets and user-defined libraries.
Yeah, I was just about to point out this difference here. Very good. What he said. Predefined libraries you're going to put in brackets, and your defined libraries you're going to put in double quotes.
I guess the asterisk that makes a line, it's just any random number.
This? All you need is 1 star, and then you have 1 star. This is another good question. That's sufficient for a comment. I put more stars to try to make it, look clean. Like you see how I have it like right at the end there. I do that to make it look clean. In order to do a proper comment, if you had 1 line, you could either do what I've done here, where I have 2 slashes, or if you did /* standard library * /, that's another comment. So anything else beyond that is just for making it look clean. Any other questions? So here what we could do is we could take that and test function that I wrote, put the function declaration void and test void semicolon in H, and then go into gates.c, write the actual declaration, and then just all we have to do is just replace this code. We could get rid of all that and just replace it with underscore and test. And that's your benefit of header. One of your main benefits of header files is you can make your main function look very clean. So what are the 5 stages of the MIPS data path? Memory. One more. Right back. Right. So a well-written final project will just have fetch, decode, execute, memory, write back, and you could have a while loop to indicate while memory is not empty, right? So that would be a very good obfuscated code segment there. And so as I've mentioned before, note that we did not include standard bool. It's not included in main C. This is because circular library references are not permitted and will cause compiler errors. Or if it doesn't cause a compiler error, it'll just cause your program to do kinds of awful things. So here I have a case where we have called parent C and child C. So in this case, you could say the child of gates.h was standard bool.h, right? So for some reason, if I had a function called gates.h, and then I had that function pound include gates above it. So let's say, so I had arithmetic.h called gates.h, right? And if I had something calling arithmetic, but then I had it, if I said pound include gates.h, so I have something pound included, then pound included, and pound included there. So every time you called it, it would have this circular reference. So it's a add this in order to add this, 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 and so forth, right? So if you're talking about memory management, what happens? Boom, exactly, right? It just doesn't work. So this is why in every project, I'm going to require you to draw up one of these library maps. And so here I have main where it's in mips.c, and there I call std out, and std bool. And then I indicate which functions are being called with each one, right? So here std out is just fprintf. Gates, I have and standard bool, I'm using bool variables, right? And so if you were doing and test, you just name and test here in order to do that. So the reason why this is important is because I found this will reduce a little bit of time from your coding if you just maintain this in real time. And you're like, okay, well, I want to add arith.h. What do I have available to me if I just call gates.h there, right? So let's say I have standard IO, I have standard bool, but I don't have some other definition, right? Let's say I want to just have some other header file that I want to call there. I would call that header file an arith and not have to worry about it because it's not being called in gates.h. But if it is being called in gates.h, I wouldn't call it an arithmetic to avoid that circular reference. And so that allows you to plan your header file out before you write any code and reduce some compiler errors. And when I will be posting my requirements for your project write-ups, I will remind you of this again. Does anybody have any questions before I go on to describe these header files in more detail? Okay, so in this case, I have gates.h. I described what this function contains the function definition for logic gates for the MIPS data path. If not defined, gates underscore h, define gates underscore h, pound include std bool.h for boolean. So my first function is and, preconditions bool a and b, postconditions bool. This function returns a, b, so before I had written the test function, test case, and I described all of them, you can then write a test case and underscore test. Just put all that in there to make it run to reduce your commenting that you have to do. So here you could say all possible test cases are in and test. And then same thing, I created an or function and did the exact same thing. And then I have my end if gates underscore h. So if I go into gates.c, I do pound include gates.h. And here's the or function. We have a similar switch statement. So I have switch A. If it's false, just return B, because if it's B is true, that'll be true. Case true, it's automatically true, so return true. So you're going to be doing that with and, or, NAND, NOR, XOR, and XNOR, right? And not gates. And then you would go back. Do you have? Oh, sorry, you don't have questions, Avery. Okay. Then you could test the or function there, and then you can actually take that and create its own or test function. And then when you compile it, you're going to get your typical or gate. Okay? And so when you do your test functions, you're going to be just calling and test and or test to print it out. On the syllabus, I had the due dates for the projects. So I'm going to the week before. So let's say the week before. Let's say it's due on the 12th. So I have that there's going to be 2 lectures before the 12th. Any of these programming problems that are done that week are not due. So you have a full week to be able to work on it, so you don't have to wait until the last lecture. So let's say we got to C programming 3.4 by the week before the programming is due, and then we did 3.6 that following Tuesday. 3.6 would not be in your coding assignment. Okay? So I want to be clear on that. So the first problem that you're going to do is you're going to develop a program that includes a library. So now you understand, includes a library for the following gates: AND, NAND, OR, NOR, XNOR, and XNOR, and then a one input NOT gate. So you must use Booleans and switch statements as described in lecture. You may not use the logical operators in C, such as simple ampersands is AND. So if you're using if statements, if A and B returns 1 if they're both true, OR and NOT, you may not use that in your descriptions of your gates. Your main driver function must test all possible gates. So just like we've described in lecture, you have AND test, NAND test, OR test, NOR test, XOR test, XNOR test. So it should print out to the screen, and I should be able to run your code and see all those test cases there. Any questions? As we get closer to the due date, I'll tell you which ones are due. So next thing I want to do is, how do you call functions within functions? So in this case, I am going to design a 3-input NAND gate. I'm going to start a 3-input AND gate using only 2-input AND gates. So here I've written a function. My preconditions are A, B, and C, and I return a bool. And this is my declaration. So now we get to our definition. So I would put this in gates.h. And then here, I've written one line of code. And so it's return AND. So AND is taking in 2 bools, right? So the first bool is, let me zoom in so everybody in the back can see. So here's our line of code. So first I have this first bool here, and so I have 2 inputs. So I have A and B, and that returns a bool, right? So now it's going to return it as the first input to this function. And then I just say C, and then it's going to return it, and that's going to return this bool. So that's how you can call a function within a function to make it work efficiently. And so I've developed the test case, and then here I have a 3-input truth table, and using the 2-input AND gate, I was able to use this, call a test case, and have the correct outputs. So that's where function reuse becomes important. So for example, if I was doing a full adder has 2 XOR gates, so you have A, B, you call XOR, so you get your sum output, and then you can use the AND and OR gates to get your carry out. So that's where developing the gates becomes important. Okay, and then I've included here, so you can look at this on the video, this is my AND3 test function. So in the AND gate here, as I've indicated, if all 3 are true, return true, else return false. And you can say it's contained in AND3 test. And then here it says this function tests all possible input cases for underscore AND3. And here it is, printing them all out. So the entire main function, all I do is AND test, OR test, here an AND3 test. For some reason I included all the ones at bottom for 2.1 here and 2.2, just so they're all together. I want 3 inputs, AND, NOR, NAND, NOR, XOR, and XNOR. So your function should call all those test functions and print it out in a way that's clear that you've done that. So you're going to create a header file. You can call it whatever you'd like. I would recommend gates.h, but that's just me. Something that you know what it is, because it's your code. It's not my code, it's your code. Okay, so we're going to wrap up here in a second. So 2.5 through, what was the last TGO we did here? Okay, so just wrapping up section 2 today. So I'm going to get ahead of this question because it's a common question. Dr. Morrison, can you post all those code that you went over in lecture today? No, I will not. No. Why? Am I a heartless Balrog? No. Or you shall not pass. And the reason why is not because I'm a heartless, but because it's just like the topical guide objectives. There's nothing that's a better teaching tool than you physically doing that. If you copied and pasted pre-written code into that, I think that's a disservice to you. And I think a lot of times, especially a lot of classes that do that, people come out and then they go to a later class and you expect them like, okay, design a project, and you have no idea how to do it because you've actually been just copying and pasting your code. So the point I'm doing this is to have you be better coders. Also, I have another meme here. I have no memory of this code. Oftentimes, if you don't write your code and you don't comment it properly, you won't remember what it is. So sometimes that's just beneficial to you as you get towards the line towards your project. So if there are no other questions, class is dismissed.